So hello everyone. This is another database, hostel mesh database for which we are going to design the ER model. So in the requirement specification is given like this. So many detailed information are not given here in the requirement specification. So just let us read out the specification. A hostel mesh database keeps track of all the available hostel mess menu, warden, and student details. Each hostel has a unique number, name, and type of hostel which give information about whether the hostel is for girls or boys. Keep track of the mess menu of each hostel to record in which day what special dishes are given for breakfast, lunch, and dinner. So we have to design the database by using ER diagram for this hostel mess database. Okay, so from the first sentence we can see that um, hostel mess database is the database. So hostel is going to be the first entity type. We have identified the first entity type as hostel. The second entity type will be the mess menu. And then we have another entity type, that is warden, and then the last entity type, that is the student. So here I'll just give some hint about the entities and then relationship between the entities here from the requirement specification, and you just means you just try to design the ER model for this particular database by yourself. Okay, so we have these four entity types. For the hostel entity type, the attributes are given like this, like unique number, name, and a type. This is going to be the uh, uh, attributes for the hostel, this one, entity type. And then we have the mess menu. So here mess menu, it says that keep track of the mess menu of each hostel to record in which day what special dishes are given for breakfast, lunch, and dinner. So the attributes will be something like that, means it will have a day will have Monday, Tuesday, Wednesday, Thursday, Friday, Saturdays, and then Sunday. And it will have other three attributes like breakfast, lunch, and dinner. So it will have four attributes. And one thing about it is this mess menu is going to be a weak entity type, okay, because it totally depend on the hostel. Okay, so it doesn't have any, the menu doesn't have any this one key attribute. We can't choose from this four attributes, we can't choose any of the attributes as the key attribute. Okay, so it will have a partial key, and they choose this day, the day will be the attribute which will be the partial attribute for this weak entity type. And the weak entity type, for this, it will have an identifying relationship between with the hostile entity type, and hostile entity type is going to be the owner entity type, or you can say the identifying entity type for the mess menu weak entity type. Okay, and the other two remaining entity type for warden and student, you means the information means detailed information is not given here in the requirement specification. You have to do some assumption, means you have to put some attribute which will describe the student entity type and the warden entity type. Okay, and you can't have an entity type without any attribute. So you have to guess, you have to do some reasoning. Okay, and then you have to decide some attributes for these two type of entity types, because here in the requirement specification nothing is mentioned. So for example, for student you can have some ID number, or then the name of the student, or sex, whether it is a girl or boys, in order to determine it. And then some other like department or semester or something like that, you can at the attributes for students. And for warden, even same thing, you can have an ID number, and then for warden some qualification like that, some required details, you just put it as a attribute for the entity type. And relationship, we have already seen the relationship between hostel and mess menu, but the other remaining relationship will be one will be between the warden and hostel, and another one will be the hostel and warden, sorry, hostel and the student. Okay, so there means you can think about other remaining other means you can mean there may be probably many other relationship can be you can build up, but the main thing means the basic thing will be there will be a relationship between hostel and warden, and then hostel and student. Okay, so this is the brief means brief information about this particular hostel mess database. Using this information, you can uh, draw the ER diagram yourself, and even for some other database also, collect some other requirement specification for some other database, and you just practice. Okay, you just practice designing the model for the databases. So it is very important to be able to design the database by using model. So you just practice a lot using a different type of databases. You can practice yourself. Okay, so that is your model. So that is the first database model for this particular course. And another important this one database model that we are going to see is a relational model. So as I have told you, this is the most popular relational model. Means this is the most popular database model that is using in general. Okay, means why it is popular? Because it is popular because of how they are representing the database. Every minute details they are represented in this particular model. That's why it is very important, and this is the most popular one. So relational model, I'll just give some important information about relational model. It was first introduced by EF Code. Okay, and then by it this particular model becomes very famous, that relational database. It means um, uh, this all these models, I'll just tell you this, all these models, whether it is an model or relational model or whatever, they are all conceptual model, means they are conceptually representing the database. We do not need, for the while designing, we do not need to understand the physical meaning of the database, how they are stored in the hard disks. We do not care. Okay, the means model, this all these models, whether it is an model or relational model, they are conceptually representing the database. Okay, these are not actual things, they are conceptual things. Okay, so relational model is also a conceptual thing. It represents the database, and in such a way that it means every details are given there in the relational model about the database. Okay, so that's why it is very popular. And then the database that is represented by using relational models are known as relational database. Okay, relational database. So we have the relational database, and then the relational database, they are going to be, means these are these are they are models, isn't it? And they are going to represent some database, isn't it? So if there is a database, then if we have a database, then there is some language related to that database. Okay, so there are two very popular language. One is known as relational algebra, and another is known as relational calculus. Okay, so relational algebra and relational calculus, they are also conceptual languages. Okay, they are not application type languages, means we can't apply it in actual in real life. Okay, they are just there as a language, and by using these languages with the other the two languages, that is relational algebra and relational calculus, we can query the relational database. Okay, we can query, means we can query means we can retrieve information from the relational database by using either relational algebra or either relational calculus. Okay, so from there we have, I'll just explain, I will just write all these things using a slide. Okay, so I was first saying this relational database, isn't it? Relational database, DB represents database. Okay, so relational database, I already mentioned it. It is the representation of a database using relational model. So it is a very popular model, and from this relational model, two type of language comes up, and that is relational algebra and relational calculus. Okay, two such type of languages comes up, which will be used in order to retrieve information from relational database. So these are all conceptual things. Okay, they doesn't exist means we can't means everything we have when we say a language. Say for example our C language, we use C language in order to instruct the CPU, isn't it? And the CPU performs some tasks according to the instruction that is given to the CPU using the language. But here relational algebra and relational calculus, they are not going to act on the computers. Okay, means they are just something there, means you can say it is a mathematical means language. Okay, you can say like that, means they exist but as a theory. Okay, so by using relational algebra and relational calculus, you can retrieve information from the relational database. From there, by using the concept of this relational database, relational algebra, and relational calculus, here comes RDBMS. Okay, so RDBMS are the popular database management systems, which is based on relational database. Means the database they are using are totally represented by using the relational model. Okay, means they depend on relational model. So RDBMS are the means I'll just mention one thing here. The first commercially available RDBMS is going to be the Oracle. Okay, Oracle. So Oracle is the commercially available RDBMS. From here you can understand that MySQL and all these things are all RDBMS, because they are using the database representation by using this relational database. They are using relational database, you can say like that. Okay, that's why they are known as relational database management systems. Okay, so the first available RDBMS is Oracle. Okay, and then from here, by when it comes to this computers and all, then another language came up, so SQL, which we can use in actual life, means which can be used to actually retrieve information from the databases. Okay, and SQL are normally going to retrieve information from the relational database again, and SQL use relational algebra as the core language for SQL. Is the means relational algebra is going to be the core language for SQL. Okay, means it is totally depends, means it comes up because of relational algebra, because we have relational algebra, and it this particular SQL we can implement by using SQL in our computer, and it is means all the means what to say, all the knowledge and everything, it is based on this relational algebra. Okay, because relational algebra is the core for SQL. Okay, and SQL, by using SQL you can retrieve information, or you can query the database as means this modern databases. So we have our modern databases. So modern databases can be some object-oriented databases, or it can also be an RDBMS. There are many modern databases. So these are all, they are all comes up because of this relational algebra and relational database that was first introduced by E.F. Cott. I will just write the name, E.F. Cott. Okay, so because of this relational algebra and the relational database, we the means the RDBMS and modern database and then SQL, they are existing. Okay, they come up because of this relational database and relational algebra. That's why I'm saying relational model is a very important database model, and this is the most popular database model. Okay, so let us come to the relational model again. So this is the first one is the, you can it is a brief definition about relational model. It represents the database as a collection of relations or tables. So in some simple word, you can say table, but I don't want you people to use tables because this is not the correct word. The correct word is relation. Okay, so each and every table, it will look like a table. Okay, that's why it is terms, and another terminology for it is table. Okay, but we will name it as, we will term it as relation. Okay, so a relational model or a relational database contains a collection of such tables or relations. It will have many tables or it will have many relations. So these relations and the relation set that we see in ER diagram, ER model, they are totally different. Okay, they are totally different. Just remember it. Relations can be used to represent an entity type in the ER model, from the ER model, or it can also represent a relationship type from the ER model. So ER model is representing the entities and the relationship between the entities, isn't it? So this relation can be used to represent an entity type, or it can be used to represent a relationship type. Okay, and then what is this table or relation? It is a collection of rows or records or tuples. Again, the rows and records, we are not going to use these two terms. We will use tuples. Okay, so this is a standard term that we are going to use, means standard term for relational model, so we will use it. Okay, we'll use the standard term. So it is a collection of tuples. Tuples are, if it is a table, then we will have rows, isn't it? In a table it has rows, so tuples represent the rows. It is the rows. Okay, contains values related to each other, means tuples contains values related to each other. And then what about domain? Domain describe the types of values that can appear in each column or attribute. Again, we will not use the term column here. We will use the attribute. So each and every column it is going to have some heading or something. Okay, and that is known as the attribute. You can say the column name is an attribute. Attribute plays the same role that it plays in the ER model. Okay, so they are same. So each and every relation is going to have attributes. Okay, attributes that describe the relation or the table. Okay, so domain is going to be the values that can be put inside that particular attribute of that particular relation. Okay, so means it is the permitted, or you can say permitted values that can be entered in that particular table of that particular means attribute. Okay, and then what is relation schema? Relation, when we say a relation schema, what is a relation schema of a relation? It is going to be the collection of relation name and a list of attribute names. Okay, means we do not want to see the details about the relation, but only the relation name and the list of attribute it has. It will give you the this one, relation schema. Okay, of that relation. And what will be degree? Degree will be the number of attributes in each relation schema. It means the relation for for a particular relation. What will be the degree of the relation? Means it is the number of attributes it has. Okay, so that is the degree. And then what is relation state? So relation state means it will have the relation schema, plus it will have the data also, data that is stored in the relation. So it will have a list of tuples at that instant of time. Okay, we'll just see this using a table here. It is a table or it is a relation. Okay, you can say it is a relation. It is a single relation, means a relation represent a table, isn't it? So this is a relation, and it will have a name, relation name. So you can have a relation name as uh, the name of the relation for that particular relation. Name of the relation was something like live. Can name it as it can be a library, means yeah, it is a okay user. Okay, so it is a relation that is, it is a relation and that belongs to a library management system. Okay, it is a relation that belongs to a library management system. When we say a library management system is a database. So as we have already seen, database is a collection of this one, many relations or many tables. It will have many tables. Okay, so this is one such table that belongs to the library management system. Okay, and it will have a name. Relation should have a name, and let us name it as user of the library management system. So I'll give user as a name. And what are the attributes? Card number, name, address, status, and code. So it will have the attribute card number, and then name, and then address, and then status, and then code. Oh, sorry. So this is the relation that is given here. Okay, we can so this is the relation user, and it has the attribute card number, and then name, and then address, and then status, and code. It has this this five attributes. Okay, column name or attribute, you can say attribute or column name. Now there are the attributes, and then the one such row, this row is termed as tuple. Okay, they are terms as tuples. These are, it has four tuples here. See, it has four tuples. Okay, this one, and then this one, and then the third one, and the fourth one. So four tuples. Okay, so four tuples for each attribute, means for for a particular tuple, it will have values for each and every attribute. Okay, that means for a single tuple, as it has five attribute, it will have five values. This one, this one, this one, and this one, five values. Okay, so this is the relation. And then it gives you, when I say domain, what it means is for a particular attribute, say card number, it will have some domain. Okay, such as it will be a string like this. It will be a string. It should start with an L. It should start with an L, means, and then other remaining should be integer values. Okay, other remaining should be integer values, and then the uh, length of the card number, means the values should be 4. Okay, so these are some restriction that is given for this particular attribute. Okay, and it is the domain, it represents the domain for this particular attribute. Some constraints are applied here. Okay, so domain is a constraint that is applied to a particular attribute, and it will give you the possible values that can be entered here for this particular attribute. Same here again. Okay, in the name attribute, you can say then numbers can't be there, only characters should be there. Okay, character strings should be there. So like that you can put some constant, and that gives you the domain for that particular attribute. Okay, so domain is like that. And then I have mentioned some few things here, isn't it? Degree, okay, relation, domain, we have that, we know what is a domain. And then relation schema. So relation schema, the relation name and the list of attributes, something like this represents the relation schema of the particular relation user. Okay, it is the relation schema for user relation. Okay, because it has the relation name and the list of attribute names, so it is a relation schema. And then what are the other things? Degree. So what will the degree for this particular relation? It has the degree 5 because it has 5 attributes. That's why it will have a degree 5. And relation state. Okay, so at means it will have the relation schema, this one, plus the values that is stored in the table or the relation, that is this values at that particular instant of time. Okay, but after some time you might delete some tuples, isn't it? Or you might enter some more values to this relation. Okay, so it means that the state of the relation might change. Okay, every time it might change. Okay, so when we say a relation state, it means the list of tuples that at that instant of time. Okay, so that means this one, that is, it is the relation schema plus list of tuples at that instant of time. Okay, so the other things about relational model that I want to say is here uh, in here in each tuple. See, in the first tuple here, in the first tuple, the values that is given for each and every attribute, there should be an atomic value. There can't be an composite or multi-value. Okay, they can't have multi-values. It should be an atomic. Okay, only a single value should be given for each and every tuple. For the attributes, for each and every attribute, value should be an atomic value. We cannot have composite attributes or we cannot have multi-valued attributes. Remember this. Okay, and the other thing about it is, if some for a particular tuple, if the value of some attribute we do not know about it, then we can have a null value. Say for example, for this one, for this particular tuple, for this tom, if we do not know the address, then we can just have null value here, like this. Okay, we can have null values here in the table also. Okay, so that is the relational model. So in the relational model, again, as in the entity relation model, you can choose from the attributes, you can choose any one or more attributes to be a key attribute. Okay, to be a key attribute. So if there is a key, then what it means is the key attribute can be used to uniquely identify each and every tuples. Okay, that means key attribute should be able to perform, that means it should be able to perform that particular definition of the key attribute. Okay, so that means we can choose this card number as a key attribute or code as a key attribute, or you can combine these two, card number and code, and you can have the combination of these two as the key attribute. Okay, because see, means L001, this card number is going to be unique for sure. We know this, isn't it? From the real life perspective, we know that card number are going to be unique for each and every person. Okay, so that means you can use card number as a key attribute, because by using the value for the card number, you can uniquely identify the other remaining values, isn't it? The other remaining values will automatically come up, like in for your particular, means for you people, by using your enrollment number, you can derive the other details from the student database, from your MIS or whatever. You can derive the other this one details of that particular student, isn't it? So like that, you can use this card number in order to determine the other things. That is what uniquely identifying the tuples. Okay, So you can use card number or as the uh, key attribute. You can't use something like name, because there may be more than one person may be sharing the same name, isn't it? So you can't use name as the key attribute, and you cannot use, it is not possible to use address as the key attribute again, isn't it? Again, status here, see, there are many people who is having the status as faculty, and then some are using having the status as student, isn't it? So you can't use status as the key attribute. But quote is again some number that is given to the person uh, to uniquely identify it. So you can use quote also to be the key attribute for this particular relation. Okay. So we have seen what is a relational model and some of the terms that we'll be using, like a relation and then the tuples and then the attributes, and then domain, what will be the domain, and then relational schema, and then degree of the relation, and then the relational state, what is the relational state of a relation. And then we have seen an example relation here. It is a single relation. Okay, when we say a database are actually a huge uh, thing where we can store details about related related things. Okay, so this is an example relation which belongs to the library management system. Library management systems might contain and different such type of relations. Okay, means it may contain more than 10 to 20 relations. Okay, and again, each and every tables, it is not going to have something this like four tuples that is showing here. Okay, it will have thousands of tuples. Okay, because thousands of peoples are using in the library database, isn't it? So that's why thousands of tuples will be there in this particular table. Okay, this I'm showing only some few tuples here in order to explain it. So remember this thing, there are going to be a huge data will be stored in our database. Okay, so that is relational model. I will continue this relational model in the next class also. So that's it for today.